not a lot of 1D kinematic questions when it comes to free responses, so you actually kind of have to dig to find any, and really you don't see ones that are full out. So we do have something here, though, part of one that I'm going to go over. So you've got two gliders move freely on an air track with negligible friction as shown above. Glider A has a mass of 0.90 kilograms. Glider B has a mass of 0.60 kilograms. Initially, glider A moves towards glider B, which is at rest. The spring of negligible mass is attached to the right side of glider A. Strobe photography is used to record successive positions of glider A at 0.10 second intervals over a total time of 2 seconds, during which time it collides with glider B. And we have the following diagram represents the data for the motion of glider A. Portions of glider A at the end of each 0.10 seconds interval are indicated by the symbol A against a metric ruler. The total time elapsed T after each 0.5 seconds is also indicated. And part A asks you to determine the average speed of glider A for the following time intervals. And so this actually is a typo, but it's 0.10 seconds is supposed to be the time interval. So anytime you're going to do any sort of problem for a free response, you always want to make sure before you plug into any equation that you state the formula that you're going to use. It helps your work to be more clear. Sometimes stating the formula actually gets you points on the rubric for the AP free response. So I do have here my formula that I'm going to use, which is average speed or average velocity equals to the change in distance divided by change in time. So for part 1 of part A, I'm asked to find the average speed from 0.1 to 0.3 seconds. So I look at my scale here, and at 0.1 seconds, because each little marker is 0.1 seconds, I'm at 0.1 meters, and at 0.30 seconds, I'm at 0.30 meters. So I plug into my formula, and I find that the average speed there is 1 meter per second. For part 2, same idea. At 0.9 seconds, we are at 0.6, 0.7, 0.8, 0.9. We're at 0.87 meters. And at 1.0 seconds, we're at 0.99 meters for an average speed of 0.60 meters per second. For part 3 of this, we're going from 0.70 right there, which is at 1.14 meters, to 0.90, which is at 1.18 meters, and we get an average speed of 0.20 meters per second. Each one of these was worth 1 point on the AP rubric, and this one just does award the answer. Sometimes they will award for just the answer. Sometimes you have to have work in order to get the full credit. So I always recommend showing the work no matter what, because you don't know what the rubric's going to ask for until you see the rubric, which you can't see while you take the exam. Then for part B, you're asked to sketch a graph consistent with the data above of the speed of the glider A as a function of time for the 2 interval second. So careful here, because a lot of people want to just start plotting these points out. That would be if you're doing a distance versus time graph. Here we're doing velocity versus time. So if you look here, your velocity stays constant for the first 0.7 seconds, and so you need to show that 1 meter per second. Graphing that part correctly was worth a point on the rubric. And then down here, again, once we get past the 1.2 seconds and onward, we get that another set of consistent speed of 0.20 meters per second, which is something that we found in parts 3. So we graph that. That's another point, and then having that change in velocity here was worth a point. They said you could either have it be distinct straight lines, or if there was slight curves, that also received full credit. So that was, I believe, another 3 points. Let me check real quick. And yep, that was worth 3 points. So 1 point for using the correct values, and that will get you that. Okay? So that's a quick demo. Hopefully that helps.